Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
Just now, a chilling discovery was made. Lights flickering on Proxima B. Orbiting our closest star, this mysterious planet was captured by the James Webb Space Telescope, revealing hints of a possible civilization thriving in its habitable zone. What secrets could be lurking on the dark side beneath those eerie lights? Join us as we venture into Proxima B's shadows and uncover the mysteries waiting to be exposed. Our closest exoplanetary neighbor. Scientists have recently found a rocky planet that orbits Proxima Centauri, the closest star outside our solar system. This planet, called Proxima B, is the closest exoplanet ever discovered. Thanks to the powerful James Webb Space Telescope, which was launched in 2021, astronomers are now exploring space like never before. This new tool has opened up an exciting time for space discoveries, especially about Proxima B, which is only a little more than 4 light-years away from us. As the world waits in bated breath, a new signal, strange and seemingly intelligent, has been detected coming from its direction. Proxima B is located in what's known as the habitable zone, an area where conditions might be just right for life. However, there's a catch. The planet is tidally locked, which means one side of the planet always faces its star, getting constant sunlight, while the other side is in permanent darkness. This presents both challenges and opportunities for scientists thinking about the possibility of life or even future human settlements. On the side that always faces the star, it's warm and bright all the time. Meanwhile, the dark side is much colder. This extreme difference could lead to interesting weather patterns as the heat from the sunny side tries to spread to the dark side. Such conditions would make life on the planet very different from what we know here on Earth, where the day-night cycle helps maintain natural and biological rhythms. If there were any advanced civilizations on the planet, they would have to figure out smart ways to deal with the extreme climate. They might use advanced technology to transfer heat from the sunny side to the dark side. For example, they could build networks of cables to move heat and energy between the two sides, balancing out the temperatures. The James Webb Space Telescope could play a key role in helping us find signs of these advanced civilizations. One way would be to detect artificial lights on the dark side, a clue that intelligent life may exist there. But even if we don't find any, the telescope is helping us understand more about planets like this one and pushing us to think of new ways to explore space. But here's the thing. The planet is not just another discovery. It challenges our creativity and ability to adapt to new and extreme environments in space. This planet serves as a reminder of how much we still have to learn and how far we've come in our journey to explore the universe. With new tools in hand, we're now exploring if distant planets like Proxima B might actually have civilizations. Detecting life in distant worlds. Just think, a civilization on Proxima B could be using incredible technology to create a balance between the two sides. Maybe they have huge networks of energy systems to move heat and power across the planet. That makes us wonder what kind of technology we would need to detect such advanced civilizations. We're using the James Webb Space Telescope to search for signs like artificial light or other signals that could show us an advanced society exists there. Finding such signs would not only give us a deeper understanding of other planets, but could also push us to invent new technology to explore these distant worlds. Proxima B is an exciting challenge for scientists, inspiring new ways to think about how life could survive in such extreme conditions. The possibility that we might detect artificial lights, perhaps from cities or other technology, opens up thrilling new questions about life beyond Earth. These kinds of observations, though still being studied carefully, could represent a turning point in our ability to find advanced civilizations. It would not only change our understanding of what makes a planet habitable, but also force us to reconsider our place in the universe. Discovering such technology could transform how we search for life, giving us new tools and methods in this exciting quest. As we look more closely at this planet with the James Webb Space Telescope, we're learning a lot about its atmosphere and the conditions that could make it habitable. By studying important molecules like water vapor, carbon dioxide, and methane, scientists can figure out whether the planet has the right kind of environment to support life. These careful studies help us learn more about distant worlds and improve our understanding of how planets work, which is crucial in our search for life in the universe. But here's the thing, it's not just about the science. Studying this planet connects us to some of the biggest questions humans have ever asked. This planet, circling the nearest star in its habitable zone, feels like a place where we could find answers to questions that have fascinated us for centuries. As we keep analyzing the data from the James Webb Space Telescope, we might discover that life-sustaining planets are far more common than we ever thought. This could make us rethink everything we know about our place in this vast, possibly crowded universe. As we explore worlds very different from Earth, we face big challenges from a distant and dangerous star and its effects on this planet. This journey into the unknown brings us face to face with the unstable behavior of its host star, Proxima Centauri, which is an M-dwarf star. M-dwarf stars are very common in our galaxy, but they bring their own unique set of challenges for making planets livable. They are known for sending out very strong solar flares much more often and with more power than our sun. These flares release huge amounts of radiation. This radiation can strip away the atmosphere of planets very close to their stars. Losing an atmosphere is a big problem because it acts like a shield, protecting the planet from dangerous radiation from space and the star. To make matters worse, M-dwarf stars stay active for much longer periods compared to bigger stars. So this planet could be facing these harsh conditions for billions of years. This long exposure to harmful radiation can seriously limit the chances of life developing or surviving there. The constant flares make it really hard for the planet to keep a stable atmosphere that could support life. As we learn more about Proxima B's harsh conditions, we find out just how tough survival there could be, exposing the mysteries of Proxima B with the power of JWST. But that's not all. The high-energy particles from Proxima Centauri can also damage any existing ozone layer the planet might have. Without an ozone layer, the planet would be exposed to dangerous ultraviolet UV light, which could harm or kill any life forms by damaging their DNA. However, this isn't the worst part. Even though the conditions on Proxima B seem extreme, the fact that life on Earth has managed to survive in tough places gives us a small hope. Maybe life on Proxima B could adapt in ways we haven't imagined yet. Our curiosity about this planet keeps pushing us to explore further, and each new discovery helps us learn more about both other planets and how life can be incredibly tough. We are using some amazing tools like the James Webb Space Telescope to help with this exploration. It's equipped with advanced technology like the near-infrared spectrograph and the mid-infrared instrument, which help us study planets far away. These aren't just simple cameras, they are complex tools that break down light to study it in detail using a method called spectroscopy. Spectroscopy helps scientists find out what gases and materials are in the atmospheres of planets like Proxima B. NIRSpec can look at the near-infrared part of the light spectrum and catch small traces of light that pass through or are given off by a planet's atmosphere. This can show if there's water vapor, methane, carbon dioxide, or other signs that life might exist. But that's not the end of it. MIRI works on a different part of the light spectrum, focusing on mid-infrared light. This is great for looking at cooler objects in space, and it's also really useful for studying Proxima B's weather and climate. It can even see through dust clouds that block other instruments, giving us a clearer picture of the planet's surface and atmosphere. Together, these tools give us a full picture of Proxima B, helping us understand if it could support life. Every bit of new data brings us one step closer to answering that big question, not just for Proxima B, but for planets in general. What makes a planet livable? But this isn't just about science. Our search goes beyond just gathering data. It's about understanding our place in the universe. As we study the atmosphere and possible signs of life on Proxima B, we are also exploring deeper questions about life itself. What kinds of worlds can support life? Could there be life out there that we've never even imagined? These discoveries might completely change how we think about life and intelligence across the universe. Matter is packed into a super small space in black holes, creating a powerful gravitational force much stronger than anything we experience here on Earth. But black holes aren't just about their intense gravity. Scientists believe they have three main parts, each more interesting than the last. Let's take a closer look at these parts. First, we have the event horizon. Think of it as the boundary of the black hole. It's the point where, once something crosses over, there's no coming back. Whether it's a speck of dust or a beam of light, once it passes the event horizon, it's trapped and pulled into the black hole. Next is the photon sphere. This is just outside the event horizon, and the gravitational pull here is so strong that even light can't escape. Instead, light particles, or photons, actually orbit the black hole at this point. At the very center of the black hole is the singularity. This is where things get really strange because the usual laws of physics no longer apply. In the singularity, matter is crammed into an incredibly tiny space, holding all the mass of the black hole. Despite these challenges, we're drawn even deeper into the universe to uncover the secrets of black holes. First glimpse of a black hole. In the year 2021, scientists made a groundbreaking discovery. They captured the first clear image of a black hole, specifically the M87 black hole in a large galaxy in the Virgo constellation. This was a huge deal. Using the Event Horizon Telescope, a group of astronomers from all over the world worked together to create a picture of the black hole's shadow against a glowing gas backdrop. In our own galaxy, the Milky Way, it's estimated that there are over 100 million black holes hidden from view. These black holes are incredibly hard to find because they don't give off any light or radiation that we can detect. Instead, scientists know they exist because of how they affect nearby stars and gas. Imagine that. Our galaxy is full of these invisible giants, and their presence gives us new insights into how stars and galaxies evolve. But that's not all. There's a widely accepted theory about how black holes are formed. It starts with a massive star, one much bigger than our sun. When that star runs out of nuclear fuel, it explodes in a supernova, shedding its outer layers. What's left behind is a core that collapses in on itself. If this core is big enough, it becomes a black hole, with the event horizon surrounding the singularity. And that's how a new black hole is born. And here's something even more fascinating. Mathematician Roy Kerr introduced a theory that some black holes spin. These spinning black holes, called Kerr black holes, are thought to create a ring around the singularity. The spin of the black hole affects space and time around it, making everything even weirder. Have you ever heard of wormholes? These are theoretical tunnels through space-time that could act like shortcuts between different points in the universe. Imagine space-time as like a flat sheet. Normally, we travel across that sheet to get from one point to another. But with a wormhole, you could fold the sheet and bring those points closer together. While it's an exciting idea, scientists think wormholes are very unstable. Anything trying to pass through might cause the wormhole to collapse. So for now, traveling through them isn't possible. Now, there's an idea called superstring theory, which tries to bring together all the forces in the universe. This theory says the universe might not just have the 4 dimensions we're used to, there could be up to 10. And what we think of as basic particles like electrons aren't just tiny points. Instead, they're tiny vibrating strings, and the way they vibrate determines their properties, just like different notes come from a guitar string. This might also explain why gravity feels weaker compared to other forces. It spreads out through all 10 dimensions, while the other forces are stuck in just the ones we experience. Exploring black holes and these mind-bending theories really makes us rethink what we know about the universe. It's a reminder that there's still so much out there waiting to be discovered. Our understanding of the universe is always changing, shaped by what we can perceive and understand as humans. We usually think of reality in terms of 4 dimensions, 3 of space and 1 of time. But interesting new ideas, like superstring theory, suggest there could be more dimensions out there. What we see might just be a small piece of a much bigger, more complicated universe. This constant search for answers keeps pushing the limits of what we know about science. Take black holes, for example. Studying these mysterious objects could teach us more about how space and time work, what matter really is, and how the universe itself is put together. This kind of research links the huge open space of the universe to the tiny particles in the atomic world, challenging everything we thought we knew. With each mystery we explore, we push further into understanding the vast universe around us. James Webb's revolutionary visions. The universe expanded faster than the speed of light. Every new discovery in this area has the power to change how we understand the universe, where it came from, how it's shaped, and where it might be headed. For example, the James Webb Space Telescope recently sent back a single image that shook long-standing ideas about space. This could mean we're on the edge of a major scientific breakthrough. What new things will we learn from this? And how will these discoveries change our future among the stars? The debate about how fast the universe is expanding, known as the Hubble constant problem, is another big mystery in modern astrophysics. Some scientists measure one rate by looking at stars like Cepheids and supernovas, while others get a slower rate by studying the cosmic microwave background, the oldest light in the universe. This disagreement has created a heated discussion among scientists. Are we about to discover new physics? Or did we just make some mistakes in our calculations? Could these differences push us to rethink everything we know? Maybe we need to add new particles or forces to our understanding, or change how we think about dark energy, the mysterious force thought to be making the universe expand faster. Every time we tweak our theories, we move closer to unlocking more of the universe's secrets. Over time, cosmology, the study of the universe, has changed in huge ways. When the Big Bang Theory came about, it told us that the universe has been expanding from a single point for nearly 14 billion years. Later, we found out about dark energy, which is speeding up this expansion. Each new discovery has forced us to change our view of the universe, showing how science constantly corrects itself as we learn more. There's also something called the S8 tension, which shows a big difference in how we measure the clumpiness of matter in the universe. This could mean our ideas about how the universe formed and evolved are wrong. Solving this issue might lead us to a new understanding of the cosmos, making it a key moment in the history of cosmology. And if you think that's complicated, there's more. The Flamingo Project, a massive computer simulation, is trying to solve the S8 tension by recreating the universe in great detail. Even with all this high-tech work, the universe still holds on to its mysteries, reminding us how hard it is to match theory with what we actually observe. But these challenges also present new chances to learn. By trying to solve puzzles like the Hubble constant and S8 tension, we're pushing the boundaries of technology and bringing together scientists from all over the world to collaborate and innovate. In their shared mission to uncover the mysteries of space, scientists show us how exciting and constantly changing the world of scientific discovery really is. Every challenge they face isn't a roadblock, but instead a push that sparks human curiosity and the desire to understand the universe. As we stand on the edge of amazing discoveries, these challenges make us rethink our ideas, widen our view, and maybe even reconsider how we fit into the vastness of space. This ongoing search doesn't just help us understand more about the universe. It also shows the never-ending drive for knowledge that has moved humanity forward throughout history. With the James Webb Space Telescope, we're looking deeper into space than ever before. This marks the start of a new era in space study, one filled with the potential for big discoveries that could completely change how we think about the universe. Some of the problems we face, like the disagreement over the Hubble constant or the distribution of matter, aren't just obstacles. They're valuable opportunities to push the boundaries of what we know. With the telescope's incredible abilities, we can now explore the universe's earliest moments, study the birth of the first galaxies, and fine-tune our understanding of how the universe is expanding and how matter is spread out. The real test is using this new knowledge to reshape how we think. The James Webb Telescope is ready to face these questions head-on, offering detailed observations that could lead to new scientific ideas. Whether it helps us better understand dark energy, explains the strange behavior of dark matter, or reveals entirely new laws of physics, the results will be groundbreaking. The problems we're dealing with in space science today, like the Hubble issue or the matter debate, aren't dead ends. They're stepping stones that push us toward better tools, deeper theories, and a fuller understanding of the cosmos. At the heart of this exciting adventure in space discovery Every obstacle we face opens up new doors of knowledge. The Advanced Telescope acts as the key we've been waiting for, one that will unlock some of the darkest and most hidden parts of the universe and might even reveal its most guarded secrets. But the real excitement isn't just about what we might find at the end. It's about the journey itself, the learning, the questioning, and the joy of seeing beyond what we thought was possible. And it doesn't stop there. This path isn't just about reaching a final destination. It's about constantly learning and relearning, challenging old ideas, and experiencing the thrill of discovering something entirely new. The story of human exploration is full of moments like these, where tough challenges become chances to innovate, and where the desire to understand keeps pushing us to explore the unknown further than we ever imagined. What secrets of the universe do you think are yet to be discovered? Leave your thoughts in the comments and don't forget to subscribe for more.